Welcome back from the ad break, and let's continue with our lesson. So now we are going to be working with those application questions. Let's look at our first question here. It says there, simplify the following expressions. Now, the first expression that we have been given here is 45 divided by 3, and this is multiplied by x, y squared. Now, remember, when we are simplifying these expressions, we need to remember our previous knowledge, and that is our exponent laws and how we multiply and divide polynomials. So let's see how we can work with that expression. So firstly, we have been given here a fraction 45 divided by 3. Now 45 divided by 3 is 15, so we can just say here 15, and then we have that x multiplied by that y squared. Now, of course, we need to simplify this further because now that 15 is being multiplied by that x, y squared. So, because we are multiplying a monomial with a monomial, it is just going to be the 15 multiplied by the xy squared, and that is going to give us an answer of 15xy squared. Let's look at the next expression. Now, the next expression is a binomial which is being multiplied by a monomial. So we have there a minus or a negative 15x squared y, and this is being multiplied by 1/5 plus 2y. How are we going to multiply this? Remember, when we are multiplying a monomial with a binomial, we need to make sure that each term in the binomial multiplies with that monomial. So let's go ahead and multiply. We are going to start with the integers, and if there are any variables that need to be multiplied, then we are going to multiply those variables. Of course, keeping in mind our exponential laws. If the powers have the same base and we are multiplying, then we are going to add those exponents. Let's see. So we are going to say here a negative 15 multiplied by 1/5. Now, remember, when we were working with fractions, we know that when we multiply two integers or two fractions, then the numerator will multiply with the numerator and the denominator will multiply with the denominator. But of course, to make this easier for ourselves, we can just write that negative 15 as a fraction. Then that is going to multiply with that 1/5. Or for space, let us just do it here on the side. So the negative 15 as a fraction is negative 15 divided by 1, because we remember from the properties of 1 that dividing any number by 1, that number remains the same. And we are going to multiply this by 1/5. And since we are multiplying two fractions, the numerator multiplied by the numerator, that is negative 15 times 1, that is going to be 15, and of course, that is negative 15, and of course 1 multiplied by 5 is going to give us that 5. And if we simplify this fraction now, we have negative 15 divided by 5. So how many 5s do we get in 15? Yes, we get 3 of them, and we know because we are dividing a negative number by a positive number, our answer is going to be negative. So we know that negative 15 multiplied by 1/5 will result in a negative 3. Then, of course, because the 1/5 does not have any variables, then we are just going to write these variables as they are. Let's move on to the second term of the binomial. That's going to be a negative 15. Well, firstly, we are adding in this binomial. So that's going to be a negative 15 multiplied by 2. That's going to give us a negative 30. And when we look at the variables, the x squared does not have another variable that has the same base as it, but the y has the same base as the other y in the binomial. So that means that we are going to add those exponents. Now, do you remember where that 1 plus 1 comes from? Yes, those y values of y variables that we are seeing there, they have an exponent of 1. So what is our final answer going to be? It's going to be a negative 3 x squared y. And remember, here we are adding a negative number, and adding a negative number is the same as subtracting its additive inverse. So we are going to subtract 30, and we are going to have x squared, and we are going to have y squared. Now remember, the instruction that we were given is to simplify. So when we get to the final stages here, we need to check if these two terms are like terms or not, because if they are like terms, then we would need to add or subtract them. Now, are these two terms like terms? No, they are not, because they do have the same variables as bases, but if we look at the exponents are different. Let's continue to the third question. Again, we are still simplifying the expressions. Now, we have again a binomial being multiplied by a monomial. -2 multiplied by 6, that is going to give us a -12. And because there are no other variables there, that is going to be a z, and we're going to write it as it is. Then we are adding in this bracket, then we are going to say there a -12 multiplied by a 5, that is going to be a -10. And there is that variable of a z. Now, if we simplify this further, we can say there a -12z, and adding a negative number is the same as subtracting its additive inverse, so that's going to be minus a 10z. Now, what do you see about our simplified expression? Have you simplified as much as you can? No, we are not finished, because when we look at those two terms, they are indeed like terms, which means we need to simplify our expression further. Now, -12 minus 10, do you know what the answer is going to be there? Yes, it is a -22, and we are going to still remain with that variable of a z. The fourth question there, we are still multiplying a binomial with a monomial. Let's go right ahead and multiply it. So -5 multiplied by 7, that is a -35. And then we have those variables there, which is an x and a y squared. Then we are subtracting in this binomial. We are going to now multiply a -5 with a 2. That is going to give us a -10. And again, we have the variables of y squared and an x. Now, when we subtract a negative number, it is the same as adding its additive inverse. So we are going to say here plus 10y squared x. Now, are these two terms like terms? Yes, they are like terms, because even though the x and the y have been swapped around, remember, multiplication is a commutative. But when we're looking at these two terms, they do have the same base, and those bases have the same exponent. They do have the same variable as a base, and those bases have the same exponent. So what would -35 plus 10 be? Do you know the answer? Yes, it is a -25 x and a y squared. So those variables as bases, they remain the same. Let's move over to the next question. Now we are multiplying a trinomial with a monomial. And remember, each term of that trinomial must multiply with that monomial. Now we have a 10 multiplied by 2, that is 20, and that variable will remain as a z cubed. Then we have 10 multiplied by a 7. Well, firstly, we are subtracting in this trinomial. Then 10 multiplied by a 7, that is a 70, and that variable z will remain the same. Again, we are subtracting. Then 10 multiplied by 8, that is going to be an 80. When we look at our final simplification, we must make sure that there are no like terms. That's how we know that we are finished. In the next one here, we are dividing. Now, do you remember how to divide a trinomial or a binomial by a monomial? Yes, each term of that trinomial must get that monomial. That must be divided by the monomial. So we are going to have the 30mn squared plus 10m plus 20. And remember, each of them must be divided by that monomial there. So what is our final answer going to be here? Well, 30 divided by 5 is 6, and we are going to write the variables as they are. Then we are adding this with 10 divided by 5, and 10 divided by 5 is 2. And then we are going to add this with 20 divided by 5, and 20 divided by 5 is a 4. Let's quickly go to an ad break, and then we'll see you just now.